compound shapes. Now I know I've got question 1 sitting on page 73, but these are all trapezia and they're not compound shapes, but in the next screen we're going to see some shapes stuck together to make compound shapes, and that's all top grade D. Now trapezia, you're always given this formula, whether it was the SATs paper or practice tests or old foundation papers or even higher papers, you're always given this formula. So the formula of a trapezium for its area is as follows: area equals A plus B, multiply that by the height and then halve it. Okay, so here's another way of saying it: A plus B, get that, times H and then divide by 2. So what's the A bit? I'll just shrink this down a little bit. The A is the top bit or the bottom bit, and the B is the bottom bit or the top bit. So you know, either of these two, they're going to be added to make no difference which you call A and which you call B. But importantly, the height H is definitely the vertical height and not any other slanty height that may be thrown at you. So let's just do the area of shape A, and I'll do as many as I've got space for. Let's go yellow. So this is part A I'm doing right now. So here I go. I've got area is going to be 8.4 top bit plus 11.2 bottom bit. Get my answer, multiply by my height, which is 6, and then divide that by 2. Right, let's do that very quickly with a machine. I've got 8.4 plus 11.2 and press equals. I did that. Now multiply by 6, which is the height, and now I'm going to divide by 2 to get the area of my trapezium. So the area is going to be, again, being calculator paper, I'm going to use the machine, I'm not going to show any middle steps there. That's going to be in millimeters squared. Alright, so A, B, H, substitute in the correct position and get it right. I'll do this one, I think, here in black right next to it. So this will be like the A, this is the B, and this is the H. Right? I know it's been flipped, you know, it's all pointing up towards the sky, but you know, A, B, and the vertical height, because it's at right angles to the base. So here we go. There's the A, there's the B, multiply it by the height of 3, divide it by 2. So that's 11 times 3 is 33, 33 divided by 2 is going to be 16.5. This time we've got meters, so it's meters square. Alright, and that of course is the area. Let's do this one over here. Call that the A. As you can see, it makes no difference. I mean, here we've got the bigger, the longer side, the base, if you like, flipped on its head and sticking up in the air. So we're still going to call that the A, even though it's bigger than that one there. Here we had the base, which is definitely bigger than the smaller part and the top part there. It makes no difference, as long as you get the height right as well. Here we go. So what we got for area is going to be the top bit, 76, plus the bottom bit, 42, multiplied by the height, 54, halve it. Again, punch it into the machine. 76 plus 42, press equals. Multiply it by 54, press equals, just to be sure. Divide that by 2, and we've got ourselves quite a big number actually, because we're multiplying by an awful lot. 3,186 millimeters squared. Not going to argue with that. Right, here, still a trapezium, even though it's at right angles, it just confirms that this 2.8 is the height. Let's just work down here. Right, top bit, there's your A, there's your B, and there's your H. So what we got? 3.7 plus 4.9. Get the answer to that, multiply by 2.8, then halve it. Jump straight in. 3.7, add 4.9, press equals, multiply by 2.8, press equals, divide it by 2 to halve it, 12.04. So I've got 12.04 centimeter squares worth of area. Okay, now they're not compound shapes, but they're trapezia. They're a bit of a pain, especially when they've been drawn all, you know, sticking up in the air, flipped upside down. And this one doesn't seem to have one of these little slanty edges, but in fact it's got a 90, it makes a 90-degree angle with the base. They're all trapezia. What makes them trapezia? Well, one pair of parallel lines. So that's parallel to that, and that's parallel to that, and the sides can be whatever you like. Alright, so that's a trapezium done. Here's a compound shape. This is part of question 2. What do you see? Well, if you can verbalize what you see, then you can do the maths for it. Here I see a parallelogram, here I see a triangle. So work out the area of each shape, work out the area of the parallelogram, work out the area of the triangle, and then don't forget to add them. They're not two separate shapes, it's one shape made of two different shapes, hence compound shape. So here we go. Let's do the parallelogram first. Base times height. What could be easier? 10 times 4, 40, and it's centimetres squares. Triangle. That's the bottom bit. What's that? Base times height. 10 times 5. Then you divide by 2. So 50 divided by 2, 25 centimetres squared. Please write the word total area, because you've got 3 areas floating around here. Only one is the correct answer. So it's best to have things like area of parallelogram, bam, area of triangle, bam. Total area can only mean total area. So 40 plus 25, 65 centimetres squared, and that's the total area final answer. Shape C, what do you see? I see a trapezium. Look, one pair of parallel lines only, and a rectangle. Let's just do the trapezium first. Remember, there's the A, there's the B, and there's the H. So here we go. 18 plus 24, multiply up by the height of 7, divide by 2. Please note the 9's not involved, that's part of the rectangle underneath. Get an answer for that bit. 18 plus 24 equals, times 3 equals, divide that by 2, we've got 63 millimetres squared of area. Now we're going to do the rectangle area. Dead easy. 24, well that's going to be 24 down there, but of course it's their parallel lines, it's a rectangle. So 24 times 9. Get the answer to that. That's 216 millimetres squares, and don't forget total area, that's what they want. Write down the 2 bits. 63 plus 216, get your answer, get all your marks. Plus 63, doing. 279 millimetres squared. Now I don't know if there's any more. I think I'm going to pause that bit because the next few shapes will require a bit of attention, so I think I'm going to stop now and then continue with that a little bit later on. So it's 5.3, compound shapes have just been introduced, but there's more to come.